Hello everyone, welcome to the OneClass channel and good morning. My name is Fajiroi Rome and I'm an honors Bachelor of Science student working towards med school. Today we'll be going over some commonly asked chemistry questions. The chemistry questions are both at the high school and college level. If you need some extra help with your homework or tutoring, for example, you can definitely check out the links in the description below. Okay, so with that being said, we can kick it off, get started on this session here with the first question. Let's see what we have. Okay, so this question is asking us to calculate the mass of an atom. Okay, of helium. Actually, let me just put it as they did. Helium, iron, lead. Okay, and the atomic masses for these atoms are 55.9, so 4.00 units, 55.9 units, and 207 units respectively. Okay, so then how do we solve this question? Okay, we would actually go over to our conversion table. I believe it's this one here. When you see here physical constants, they want the mass of an atom. Sorry, I can do that better. They want the mass of an atom. Okay, do they specify? And it said the answer is in kilograms. In kilograms. Okay, so the good news right here actually is that we have a conversion factor that we can use. Okay, so with that being said, okay, we would treat it as, kind of like the conversion questions, where we want to put what we have opposite of each other so that they can cancel all the units, and what we want on the same level, as in, like, if what we have is in the numerator, what we want should also be in the numerator, and what we have should be in the denominator. Let me show you with an example. For this, we have 4.00 units for helium, right? If we wanted to find out the mass in, grams first, we would say 1 unit down here and 1.6605. I'm going to write the whole number, just going to do that, and then times 10 to the negative 24 grams. Okay, but they want kilograms, and we do the same exact thing. We know that there's 1,000 grams and 1 kilogram. So now watch this. These units will cancel out, these units will cancel out, and then what you get is a value that's put in the calculator. So 4.00, okay, times 1.6605 okay, to the power of negative 24, okay, divided by 1,000. Okay, so what we get as a total for the helium one is 6.6. Let's make it the same amount of significant digits. Since they gave us 3 for the 4, we have 6.64 times 10 to a negative 27 kilograms for 4 atomic mass units of helium. Okay, so now we do the same exact thing, but this time with the iron value of the 55.9. Okay, so it'd be the same thing, 1.6605 times 10 to the negative 24 grams equals 1 atomic mass unit, and then 1 kilogram is equal to 1,000 grams. And now let's see what we get for that one. Okay, we get, let's see, 55.9 We get a slightly large number, which makes sense because we do have a larger amount of atomic mass units. We get 9.28 times 10 to a negative 26 kilograms. Okay, and if we're going to follow this trend, most likely the lead is going to be at least 10 to a negative 25 kilograms. But let's see here if that's actually the case. So we have 207 units, okay, times a 1.6605 times 10 to a negative 24 grams, okay, is 1 unit. Oops, sorry. Always remember to put your units so you actually know what you're canceling. So I'm just checking back my previous work. And then 1 kilogram is equal to 1,000 grams. The grams cancel, the atomic mass units cancel, and now we have a 207. Okay, and yeah, for this answer we have 3.44 to round it properly times 10 to the negative 25 kilograms. So as you can see, when they're weighed in just atomic mass units, it's a very small amount, well, in terms of grams and kilograms. So let's see how we did for this question. Let's see how they solved it. By definition, yep, they do have the conversion factor. It is 1.66 times 10 to the negative 24. And they do explain how we get that number, actually. They use kind of like the atomic mass units for carbon times 12. So like you want to have like the carbon 12 and then divide that by the 6.022 times 10 to the negative 23rd. And that's how they get their conversion from the atomic mass units to grams, because most things are kind of based on the carbon 12 isotope. So now, as they did here, exactly, they have the 4 units times 1.66 times 10 to the negative 24 divided by 1,000, which is what we did, and we get, yep, 6.64 times 10 to the negative 27. For the first one, 9.28 times 10 to the negative 26, and 3.44 times 10 to the negative 25. So with that being said, this is correct. Alright, so definitely a great start. We can move on now to question